Let us continue to the next part of our lecture on circular motion. Calculate the tension in the sorry, this is the 2 kg block, this is 4 kg block. Horizontal circular motion, okay? It is going in horizontal circular motion. That means one plane like this it is there. In a horizontal table, it is moving like, okay?
Yes.
So in horizontal circular motion, and it is, they are rotating like this with omega is equal to 2 radian per second, okay? Consider this is string A, consider this is string B. What you need to find out is tension in A is equal to how much, tension in B is equal to how much. This is the question. Any question in mechanics in generally will involve free body diagram to solve any tough problem, which are in forces and all. Tension is a force, so we need to find out this tension force. If I take this block, if I consider block A and block B. Block A, first you need to figure out from where you want to solve the problem, from ground or from by sitting on the block. If you are sitting on the block, this block is rotating, so that is why you need to you are accelerating. If you are accelerating, that means that you are non-inertial frame of reference.
Non-inertial frame of reference.
Take the pseudo force. So now I will try to solve this problem in 2 ways, so that you will understand how problems can be solved. First, I will solve in ground frame. Okay, you will get the same answer. So ground frame, if we see, if I draw the free body diagram to it, cut it and pull it. Once, wait a minute. Now, on this, what is the tension? Cut it and pull it. So PA, because the entire tension I'm considering to be A. So if you cut it and pull it, the TA will be in the left side direction. And cut it and pull it, TB will be in the right side direction. Okay. From ground frame, these are the forces. Are there any forces? Horizontal circular motion, you should not take this mg and all.
Okay.
Because horizontal circular motion will happen on table and all. So mg will be downwards, normal will be upwards. That will be smooth.
Yes, sir.
You don't need to take about this mg and all. If it is vertical circular motion, then mg comes into picture, because you go up and down. So now,
yes, sir.
Are there any other forces?
That's it, sir.
Okay. So now it is from the ground, a person standing on the ground. Wait. A person standing on the ground, it is moving in a circular motion, right?
Yes, sir.
So if it is moving in a circular motion with a given omega constant, omega 2 radian per second, that means that force which is responsible for moving in circular motion, it should have centripetal force, otherwise it cannot move in circular motion.
Okay. Yes, sir.
So that centripetal force is provided by these tension forces, net tension force. So if it is moving in the circle, the centripetal force should be towards the center. That means TA should be higher. So TA minus TB is equal to what? MB square or MR omega square. I need to give you here length also here. Consider this as 1 meter. Consider here at 1 meter. Okay. Consider the length also. So answer is what? 2 into m into r is how much? How much radius it is moving? 1 meter radius.
1,
Omega square is how much? 4.
4. Yes, sir.
If you take v, then you will get 1v mv square by r. If you want to take, you will get va different, vb different.
Okay.
va is equal to r omega, 1 into 2 radian per second. vb is equal to r omega, that is 2 meters into 2 radian per second, 4 meter per second. You got it? If you want to take mv
Yes,
square by r as a formula, that v will be different from a for a and v will be different for b. But omega will be same for both of them. That's why it took a simple directly omega. M into r into omega square, that is 4. R is 1 meter for this 2 kg block.
Yes, sir.
1 meter circle. So Ta minus Tb is equal to 8. Okay.
Yes, sir.
One equation. If we take the B block into consideration, cut it and pull it. So Tb. And is there any other force on B block? No.
Yes, sir.
So Tb is equal to mr omega square. That is how much kg I told? 4 kg.
Yes, sir.
4 into 1 into sorry, 2. 2 meters is the radius of the circle which is traveled by B block. So m into r into omega square, that is equal to 4. So 4 4 is 16, 16 2 is 32. Tb should be equal to 32 newtons. Okay. So substituting Tb in T, this one equation, first equation,
40 Newton.
we get 40 newtons. Ta is equal to 32 plus 8, that is 40 newtons.
Yes, sir.
Now I'll solve the same question in with what? Non-inertial frame of.
Non-inertial frame of reference.
You should get the same answers. I'll show you.
Okay.
So what is a block here? 2 kg block. There will be cut it and pull it. This is real tension, Ta. Cut it and pull it. There will be Tb. So now, because it is non-inertial frame, I'm sitting on this block. If I'm sitting on this block, there will be a pseudo force on this block.
Okay.
How will the pseudo force act? Opposite to the acceleration of the frame of reference. This frame of reference is going with an acceleration towards the center because it is moving in a circle, right?
Yes, sir.
That means pseudo force should be taken in the opposite direction. Okay, FPS.
Yes, sir.
Now, for a person who is sitting on this block, the block will be at rest, right?
Yes, sir.
If the block is at rest, net force should be 0. Left side force should be equal to right side force. That means Ta is equal to FPS plus Tb. Got it?
Yes, sir.
So Ta is equal to FPS plus Tb. What is FPS? M.
Pseudo force.
Nothing but mass of the object, that is 2 kg, into acceleration of the frame of reference. What is the acceleration of the frame of reference? R is 1 meter. Plus square is 4.
Okay.
Plus Tb. Got it?
Yes, sir.
Now, if we take the 4 kg block into consideration, the body diagram, cut it and pull it, that is Tb. There's no right, and because it is rotated, if you are sitting on this frame, there will be a pseudo force which is acting in the opposite direction. Now, for a person sitting on this block, that block should be at rest. That means Tb is equal to FPS. What is that FPS? Mass of the body, that is 4 into R is 2 meters.
4 into
Omega square is 4.
1.
4 is 16.
Okay, 4.
32 newtons is Tb. Substitute in this equation.
Yes, sir. Same.
Same answer. So Ta is equal to 8 plus 32, 40 newtons. So this is the way you can solve problems. Sometimes the problems go tough. If you using non-inertial frame of reference, the problem is becoming easy, you can take it. Otherwise, you can direct.
Okay.
Here, there's no much difference in solving the problem.
Yes.
But here, this is when you're writing for non-inertial frame of reference. Here you should say with respect to the block. Okay,
Yes, sir.
you're sitting on the block and observing. Did you understand?
Yes, sir.
Okay. There's another, that's a quality question. And another question. There's a table and there is a hole in between in the table. And that hole, there is a block mass and horizontal table, right? Now, there is a block here of mass m. It is just at the point velocity v. That velocity should be maintained constant, okay? And it is of length.
Yes, sir.
Like this, it will move in a circle. Velocity v is given, it should move in a circle. So how much is this mass?
Okay.
If mass is given, find out the velocity. If velocity is given, find out the mass. Anything can be asked in the question.
Okay.
It should, like this block has to move in the circle. If velocity is given, find mass. How much mass should be there? So that stably it will go in a horizontal circle. This is smooth table.
Okay.
So then second question is, suppose if mass is given, this mass of the block is given, find the velocity. How much velocity it should be given so that it will move in a stable horizontal circular motion. Got it?
Yes.
I hope you can solve it. Try solving it. You see this question here. First, for whenever something is traveling in a uniform circular motion, this should happen a circular motion, right? It has to go in a circular motion. You need to understand there should be
Centripetal force.
sometimes the centripetal force is provided by tension in the string. Sometimes this is provided by tension in the rod. Sometimes it is provided by friction. Sometimes it is provided by normal reaction. Sometimes it is provided by gravitational force. Sometimes it is provided by electrostatic force. So like that, the force provided might be changed, but it should have a centripetal force. Here, to see this small m block travel in a circle, stable circle of radius L, it has given a velocity v. If it has given a velocity v, so what is the centripetal force which is providing the centripetal force here? Actually, this tension in the string. Cut it.
Yes, sir. Yes, sir.
And see it. So tension in the string. So T block M is going here in a velocity. So then the tension is providing the centripetal force that is equal to
mv square
by
by r.
L. V is
Okay.
given here. So T is equal to mv square by L. And another important point is, if you draw the free body diagram of this capital M, cut it and pull it, there will be tension upwards, right?
Yes, sir.
There will be mg downwards, right?
Yes, sir.
Now, for it to be stable, it should not go upward and downwards. Otherwise, the radius of the circle will change here.
Okay.
So then the tension should be equal to how much? Mg.
It's equal to mg.
So that means mg is equal to mv square by L. Now your answer is, capital M is given information. So then V will become root over m by m into G into
L.
L. If in case M is asked as question and V is given in the question, the answer will be mv square by GL. So this is your way of approaching a question, okay?
Okay.
Then another most valuable question. One of the most valuable questions. Stable circular motion. There is a string. There is a ball. Now, when the ball is rotated like this. Do you understand?
Hmm.
This is circular motion. So length is given. The length of the string is given. So now omega is given for suppose it is rotating in a circular motion with omega. So now what you need to find out is
Okay.
uh, so you need to find out if theta is given here. If theta is given, it should rotate with so and so angle. Then you need to find out velocity for me. What is the velocity for me? What is the velocity with which this ball should go? That means omega, if you find out, velocity also you can find out easily.
Okay.
Hmm.
Bob does not have any mass.
Two questions can be asked. Velocity is given, theta is asked. What is this theta with which the
Okay.
it is going in a stable circular motion, stable horizontal. Circular motion. Otherwise, theta is given. What is the velocity
Velocity.
with the, so you can relate both of them.
Okay.
This is also called as conical pendulum kind of question. It will form a cone, right?
Yes, sir, I understood.
Conical pendulum kind of. You try solving this question. Not a problem if you don't get. Okay. Near, just like let me check.
Okay.
If you see the string when it is rotating in a circular motion, the tension like suppose this is theta, this is also theta. Okay. There will be tension like this. If you draw the free body diagram on this mass of the bob m, there will be mg downwards, right?
Hmm.
So then T cos theta should be equal to mg. T cos theta. If I'm sitting on the bob, suppose if we can solve in both the ways. There's no problem. If I'm sitting on this bob and observing with respect to bob, T cos theta is equal to mg. And if I'm sitting on the bob, it should be at rest, right?
Okay.
So if
Yes, sir.
so there will be T cos theta is equal to mg. There will be T sin theta like this. T sin theta and is equal to pseudo force. Pseudo force, which is if it is moving in a circle, pseudo force will be away from the center.
Okay.
So T cos theta is equal to mg. T sin theta is equal to pseudo force is how much? M r omega square. If you consider this to be small r, this is also not given in question, okay, but I'm considering as of now small r omega square. So if I want to, do you understand this?
Yes, sir.
Otherwise, there's other way. T cos theta is equal to mg that you will accept any day. So the T sin theta is providing the centripetal force, required centripetal force to make it move in a circle. What is the centripetal force? From ground frame I'm talking about, from ground. This I spoke about from with respect to bob.
Yes, sir.
There I have to take pseudo force. That pseudo force is nothing but centrifugal force, which is going away from the center. It should be at rest with respect to bob. That means left side force is equal to right side force.
Okay.
Then with respect to ground, the T sin theta is providing the centripetal force. It is moving in a circle with respect to ground.
Okay.
Did you get this difference?
Yes, sir.
With respect to bob, if I am solving, it should be at rest. Net force should be 0. Because it is an inertial frame, you have to take pseudo force away from the center. So if T sin theta is a force that is opposite side, pseudo force is there, the T sin theta is equal to mr omega square. This is one way of solving this. Other way of solving this is with respect to ground, T sin theta force is there. That force is providing the required centripetal force. The T sin theta is equal to mr omega square. Got it?
Yes, sir.
So now, if I want to cancel this theta, if I want to cancel this tension, so sin theta by cos theta, equation 2 divided by equation 1, that is tan theta is equal to r omega square by g. Okay. So answer will be omega is equal to root over g by r tan theta. This is one answer. Okay. If theta is given,
But you asked velocity, no, sir.
I'll tell you. If theta is given, omega is this one. If you want velocity, what is velocity? What is velocity here? So velocity is equal to r omega, right?
Yes, sir.
That r into omega is nothing but root over g by r tan theta. That is equal to root over r square by r. That is root rg tan theta. V is equal to root rg tan theta. But sometimes this r is not given to you. How much radius it should move. If it is not given to you, and here also if velocity is given, here also you can find out another popular formula you might have remembered. Tan theta is equal to v square by rg.
Yes, sir.
Yeah, from here. We don't know exam which value will be given, but this is a process to solve this problem. Okay.
Okay.
So v is equal to root rg tan theta, and tan theta is equal to v square by rg from same thing. But sometimes if this r is not given, only length of the string is given. From the diagram you can say, sin theta is equal to r by L. Here. This is the opposite side divided by hypotenuse is L. Okay.
Yes, sir.
Did you got it?
Yes, sir.
Did you understand these things?
I'm understanding, sir.
Okay. Velocity is equal to root rg tan theta. V is equal to root over sin theta is equal to r by L. That means r is equal to L sin theta, right?
Yes, sir.
Then L sin theta into G into tan theta. Tan theta can be written as sin theta by cos theta. Sorry, L cos theta. Let me check it. Sin theta is equal to r by L. R is equal to L sin theta. Why the answer is not
So
coming?
that is cos theta is equal to r by L, sir.
Why?
Because our radius is the adjacent, no, sir.
This is the radius, right? If it is moving in the circle.
It is not opposite. Sin theta is opposite by hypotenuse.
This is the opposite side, right? In this triangle. If you see this triangle, this is R, this is L, this is theta. Sin theta is equal to R by L.
Okay. Yes, sir.
Okay, let me check. R is L sin theta into G into tan theta. Tan theta is how much? Sin theta by cos theta. Then the answer will be, sin theta, if it will come outside, the answer will be sin theta into root over
L secant theta.
L secant theta.
Okay.
If the answer is looking to be root over GL sin theta, how is it possible?
I also got LG sin theta only, sir.
Let me check. V equal to root RG tan theta. It is true. R is L sin theta. That's also true. Okay. Let me check. Omega is maybe my answer here. Omega is equal to how much? V by R, right?
Yes, sir.
V by V is how much we got? Sin theta into root over L secant theta
Secant theta.
divided by R is how much? L sin theta.
L sin theta.
So sin theta cancel, right? This is not L secant theta. This is L. Now
LG secant theta.
sin theta cancel. So the answer will be L secant theta divided by L square. LG secant
Yes, sir.
divided by
GL.
LL cancel. The answer will be GL by
G by L
G by L cos theta.
cos theta.
Now this is 2. Omega is correct answer only. G by L cos theta. So one thing is V is equal to, if radius is known, V equal to root over RG tan theta is correct perfectly.
Yes, sir.
Otherwise tan theta is equal to V square by RG. If V and radius are given, that is another way of doing it. If omega is asked, that is root over G by L cos theta. In term, can you hear me?
Sir, I can't see you, sir.
Okay. V is equal to RG tan theta if R is given as information. Tan theta is equal to V square by RG if R is given as information. If R is not given in terms of L, you need to find out velocity is equal to root over sin theta into root over L secant theta.
Okay.
This one, this formula, sin theta into root over LG secant theta. If omega is asked,
Yes, sir.
root over G by L cos theta. Got it? Got it?
Yes, sir.
From this one observation you can make. What is that observation? If theta is increased, cos theta will decrease, right?
Yes, sir.
Omega will increase
Okay.
because theta and cos
Theta is directly proportional to omega.
will decrease. If cos theta is decreased, omega will increase. Omega will increase means what? If you are rotating it with a higher angular speed, then what will happen? This angle will increase, right?
Yes, sir.
You know this practically. The more
Yes, sir.
angular
Yes,
velocity
sir.
increase, the theta of rotation will increase.
Yes, sir.
One important formula. So examiner can ask anything. He might give you r, tan theta, and we might ask you velocity. He might give you a velocity r, and he might ask you that angle. Or otherwise, he might give you, ask you omega, giving that information about theta. So anything can be solved by using that resolution and solving the problem.
Yes, sir.
This is conical pendulum. Conical pendulum and circular motion and conical motion. Okay. Similarly, did you understand this?
Yes, sir.
Similarly, there is another question. Like a ball is given, a hemispherical ball is given, and the ball is kept here, and which is actually rotating in a circular motion like this. Okay. Radius of r. Now, the question is, with what omega find the angular velocity for stable horizontal circular motion? Find angular velocity for stable horizontal. Circular motion. Got it? And the radius of this hemisphere is what? Capital R.
Yeah. Okay.
And mass of this blob is m. So you can try solving this. Well, actually, see, you see, if you draw free body diagram for this ball, there will be a normal reaction like this, okay? Which is what? Perpendicular to the surface, right? That means it will pass through the
Yes,
surface
sir.
like this. Now, you try to find out if this is theta, this will become theta, right?
Yes, sir.
This is n cos theta, and there will be n sin theta, right?
Yes, sir.
There will be mg, right? Normal reaction like this. So n cos theta is equal to mg. N sin theta is providing that centripetal force. That is nothing but mv square by r,
Okay.
or otherwise m r omega square. Got it?
Yes, sir.
Your answer will be tan theta is equal to cancel r omega square divided by g. Your answer will be, are you getting this?
Yes, sir. Understood, sir.
Omega square is equal to nothing new, the similar situation to the
G by under root G by R tan theta, sir.
under root g by r tan theta. But question
I got,
omega.
but there is a little bit doubt I had, sir.
So now, but r you might not know. You might know the radius of the hemisphere. Then what?
Yes, sir.
So then from the diagram, sin theta is equal to small r by capital R. If you see, this is small r, this is capital R, this is theta. Sin small r is equal to capital R sin theta. Got it? Then the answer
Yes, sir.
g by capital R sin theta. In numerator, this is tan theta. Sin theta, if you cancel, root over g by r cos theta, like the previous question only.
Yes, sir.
It depends on what is the examiner asking. Here g by l cos theta. Here this is g by capital R cos theta.
Yes, sir.
I hope you are getting clear. Anywhere when centripetal it is moving in a circular motion, you try to find out centripetal force, which is providing the centripetal
Okay.
force. Then you resolve according to the situation, and your problem will be in front of you.
Yes, sir.
Okay. Then okay. Shall we stop here today?
Yes, sir.
Okay. We'll continue in the next class.